Imagine you're a detective trying to find a single fraudulent transaction in a mountain of a million legitimate ones. Now imagine you've never been given a clear example of what that fraud even looks like. This is the exact challenge facing auditors in mental health care billing, a system so complex that anomalies, whether intentional fraud or simple errors, are incredibly difficult to spot. This is where AI can help, but standard methods often fail when there isn't enough labeled data to learn from. This paper explores a creative solution to this problem of label scarcity. The researchers knew they couldn't just train an AI on the few known examples of fraud. So, what's the trick? They developed a two-step process. First, they used a Scout AI to do a preliminary sweep. This Scout, using methods like isolation forests or autoencoders, sifted through all the unlabeled billing data and placed a temporary, maybe suspicious, flag on the entries that seemed most unusual. These flags are not perfect, but they serve as pseudo-labels or educated guesses. Then, a more powerful, detective AI takes over. This detective is a hybrid, combining two different deep learning models to get the best of both worlds. One part, a long short-term memory network, is an expert at understanding sequences, like the timeline of a patient's treatments and billing codes, spotting when the story doesn't add up over time. The other part, a transformer, is brilliant at seeing the bigger picture, understanding how different parts of a billing claim relate to each other, no matter how far apart they are. By training this sophisticated hybrid model on the data with the Scout's pseudo-labels, the AI learns to recognize the subtle patterns of anomalies without ever needing a large, pre-labeled dataset. The results on real-world mental health care data are promising. On one of the more complex datasets, the team's hybrid model successfully identified a remarkable 74.4% of the real anomalies. This metric, known as recall, is crucial because it tells you how much of the actual fraud you're catching. Of course, there's a trade-off. To achieve such a high catch rate, the system also flagged some innocent transactions, meaning its precision was lower. This is a classic challenge in detection. Do you cast a wide net to catch all the criminals at the risk of questioning some innocent bystanders, or do you use a smaller net and risk letting some slip through? This work shows that we can build powerful AI systems for environments where the truth is rare and hard to find. It pushes us to think about how AI can learn not just from facts, but from its own structured intuition. This raises a fascinating question for the future. How do we best tune these AI detectives to be both vigilant and fair? If you enjoyed this breakdown, don't forget to like, comment, and subscribe for more AI research made simple.